So today we are going to talk about the Kubernetes and a way to think about the Kubernetes as an infrastructure, as a code for your application. So not only the infrastructure you are going to build, but also the containers you're running on top of the Kubernetes, but also the deployment of Kubernetes. So how we are going to manage the initial cluster, but also the secondary operation, like upgrading, patching, and so on. So I'll begin with my speaker info. Like I said, I'm Kamil Rogoń. I'm DevOps architect. I was working with software-defined stacks previously to make them better for the enterprises. Now I moved to some smaller companies. I mentioned Doc Planner to help them change the way they think about the IT to modern way of thinking. And in my free time, I like to get engaged just before the bungee jumping, but not the way I do it more than one time, unfortunately. Sorry about that. The bad news is that I've got some marketing slides, but the good news is that it won't take me longer than 30 seconds. So I come from Container Labs. Our expertise is based on the public clouds. I know it is for some purpose, but I see some podium here. Not sure if you are seeing the same. But we also have knowledge about private clouds, so bare metal is also included, like my previous experience with Intel company. We also gave trainings about cloud-native technologies, like mentioned here, Kubernetes, but also Mesos, DCOS, and other tools for infrastructure management, like Kafka, Terraform, or SaltStack, and the Kafka for a way to be closer to prepare for the big data analytics and other streaming. Our projects are quite famous, I would say. I probably can speak for all of them, as they are NDA under that. But I for sure can speak about the Cloud Native Computing Foundation, which stands for the Kubernetes itself. We built there a cluster for the community purposes. And each product that is open source can take those infrastructure for your purposes, for the purposes of the CD, for the purposes of scale testing your application. And it's for free. Okay, the agenda. I'm going to speak why even we talk today about the Kubernetes and what's the difference between Kubernetes and the OpenStack, which was famous some time ago. Then there would be some intro to the infrastructure as code, really short intro because we are on the DevOps conference and everybody should be familiar with that. Another way then I will be speaking about the architecture of the Kubernetes, why I think it is well designed to be ready for DevOps experience. And then one of the installation tools that I'm using with my customers. Okay, why Kubernetes? So I said that the Kubernetes is now very popular. I'm not sure how about you, I see very hype on the Kubernetes, similar to the hype that was with the OpenStack some time ago. And you can see similar from the Google Graphs trends. But what's the reason that OpenStack is now on the lowering curve? However, Kubernetes is going up continuously. There are many factors about that. For example, the question to the audience. How many of you experience deploying Kubernetes? Okay, many of you. Did this experience was painful? Yes and no? I see some painful. Okay, now a question. How many of you deployed OpenStack? And the following question, did you suffer any pain? Okay. That was my intention, to combine those different technologies, because by architecture basic components, we are having two different tools that are well used and well famous in the community, alike by the community, or only a small piece in the history that will arrive and go away. Like currently, OpenStack, for example, is focusing only on the telco-specific purposes, not for the intention it was invented. Sorry. Okay, so why do we even need orchestration for our containers? Just because it's much easier to deploy container in single machine than in multiple machine environment, multi-node. What will be the difference? Of course, we've got, for example, need for the dependencies between different containers. One have to be deployed previous than the others because it depends on, like, for example, the database we need to have up and running before our application is up and running. Of course, we have we need some replication of our application because that's the way the production works. We want to have our application scale dynamically. What's more, we need also some load balancing once we're having multiple replicas of the application. We need also the rolling upgrade, which is cloud-native approach to put application to production, to move one by one version and delay the previous one, or 2 by 2, depends on our needs. We also need some service discoveries to not hard code anything. We only need some API for authentication to manage those resources. This is necessary for our automation part. And last but not least, we need some monitoring and health checking. We are running this on production. So what even the orchestration means when it is suited in the stack? So this is presented on this graph. So the scheduler and the service management and the resource management, those are those components that are built into the orchestration role. Okay, going now to infrastructure as a code. As being said, it's just a trivial. The first step to build DevOps team is to have CICD. This is a simple example from AWS website. The way you have to think is to treat ops and dev the same way. Both, they have to prepare some code. The code have to be built, pushed to repo. Previously it have to be reviewed because no one wants to be single person responsible for everything on production. Then everything is being tested and pushed to different environments, either one by one, or with some testing after that. And that's it about infrastructure as a code. Now let's summarize the benefits. We've got versioning, so we can get back to the time, to some snapshot in the time previously. Sometimes it is possible from this snapshotting in time to roll back our configuration. We can also blame somebody for making some changes. What's more, we've got automated deployment to many different environments. It's the same process to put our infrastructure on the production environment and on the test environment and other staging environment and so on. The same process, only with some parameters. Like we don't need the same amount of compute resources on each environment. We've got also change management, which is like mentioned before, a plan, like in Terraform, and we can view what will be changed, and a review that is being made by human. Also, we've got this testing quality control CI, and I would like you to think for this point for some time and note it in your hand that currently we as a DevOps, we are better at hitting power button instead of really troubleshoot the problems. That's what these CI/CD and DevOps tools give us. Last but not least is the single point of information. So there is no single human that is responsible for the knowledge of the whole company. And like tools with the Terraform, this single point of information, it also being stored as a declarative approach. So are defining not what you want to do with your infrastructure, but what you want to achieve as a desired state. And the last thing that comes with this infrastructure as code paradigm is the battle, either we use immutable or Meetable infrastructure. So I would like to summarize just what are the pros and cons of immutable infrastructure. So we've got consistency about nodes. Or one step before, do you know what is immutable? Immutable? So the difference is that immutable, you are making in-place updates, whereas in immutable, you are just replacing the whole part of your infrastructure, usually some instance, some compute, with a completely new version. Like in AWS, you will build the completely new image and run it from the new image. So from the other props, you've got you are limiting the dependencies. For example, can you guarantee me that all your infrastructure that is running Puppet, Salt, or Ansible will not suffer you from single RPM timeout or any other dependencies that are for the third-party resources that we are using? We also fail faster because we can detect problems during the build of the image before putting it to a newer version. For the cons, we will increase our deployment time usually due to this building time of the new images. And we also have our objects up and gone. So we have to be prepared to have centralized loggings and metrics for all of the things. Okay, and how it is run in Kubernetes. So this is high-level architecture proposal. The main thing is it's being separated to the master nodes and the worker nodes. You can see at the bottom there is a distributed database at CD. On the master nodes there are also components like scheduler, like different type of controllers for managing different objects of the Kubernetes. And there is central API server. This is very important because as we can see or we cannot see from this picture, it's the main endpoint for all services, not only for the users that are coming to the API, but also for the internal services. On the worker nodes, we've got Kubelet, which is the daemon responsible for managing our containers and the runtime, and other services like Proxy providing NAT services and so on. We can simplify that architecture. We as a user have different protocols to connect to the master services. Then the master services are communicated communicating with nodes, bidirectional, to manage the services. And to simplify to even more, we've got users, we've got API, and we've got managed cluster resources, containerized. Okay, a few more sentences about these internal services. API, like being mentioned, is a front end for accessing this distributed database. So we are not writing anything by your own hand directly to the database. There is also a feature for the authentication. There are plenty of plugins being implemented. Like you can use certificates, tokens, external proxy, even OpenStack Keystone, or any password files, whatever you want. And the last important thing is every changes to the API are being validated for the specification of the object that you want to change. We'll back to this later. About this distributed database, the etcd is used by the purpose. This purpose is the feature called watching for changes. So you are not constantly running your request to the API, asking, hey, something changed or not? It's like a web 1.0 when you are running pull request, long pull request. And it's similar. You are opening a connection and wait for the changes. And so the database will notify you if some new object is created or updated or deleted. It has also a feature to put objects in key value like a tree file system. That is very fine for the debugging. Like we can do list objects, cutting objects like a file system. And one more thing about this etcd is it stores states of the object in two versions. One is the desired version of the object we want to achieve from the infrastructure. And second one is our current status of this object. So by combining those two status, we know that something has to be changed. Okay, going to the controller manager. It's a combination of different controllers that are running on the infrastructure. So the flow looks like that. For example, replication controller notices that you want to run new container. So it creates this container. Then a scheduler notices, hey, I've got new container. I have to put it on the node. So I have to assign into the node that have enough resources that is capable of running my application due to the constraint that I put in the specification of the container. And then the last way, the kubelet, the daemon interacts with the runtime, creates those containers. So scheduler is by default also some simple version of the controller manager. It's got specific job to do. Get new container, assign a node for this container. Proxy is not very important in that part. Just to mention, it provides the NAT for your containers that every pod, so pod is like an implementation of a container for the Kubernetes, allows you to communicate with each other in whole cluster. And this kubelet interacts with different runtimes. So any runtime that implements container runtime interface is capable of running Kubernetes right now. It also provides root directories, this ephemeral storage for containers, and also export some metrics using CAdvisor for the Docker container. Okay, this specification file, how it looks like. This is the simple, very simple example of the specification. It defines object type deployment. And we've got some metadata of this deployment specifying that there is a generation number 32, meaning we've got previously any other versions of this specification for the deployment. We've got some deployment-specific information, like how many unavailable containers we can satisfy during some upgrading. So if we can just kill one container and wait for new to become available, either we can starting by creating new one, and when it's ready, then switch to this new container, or we are not cloud native and you have to delete all and start all from the scratch in new version, because it will not work like that. You've got previous version and new version, and your load balancer will put you to random version of your container. So by putting this specification into your production, it will give you some kind of the boxes. Deployment will create replica set, which manages number of replicas for your container. This creates the pods, and pods are creating containers. We can think that way. Replica set. We have some specification of pod with 3 replicas. We've got 3 pods created, and the job for the replica set is to ensure the replication in the specified version of replica. So we got 3 in this example. Sorry. So whenever the container C dies, in immutable way creates a new container called D in the example. The deployment creates, like being said, replica set. So whenever we are making changes in the deployment, we are actually creating the whole new replica set. So we are having this snapshotting in time. We can see the previous generation of the specification was created for that version of replica set, and we can track those all things that were in the history. We can also roll back to this previous version whenever our deployment fails to the newer version, even automatically. And there are also 2 more features to separate the code and separate your configuration, like you are having your universal containers for all of the environments, but you want to specify different either configuration files or the secrets for different purposes. And you can do it in 2 ways, either using some environment file, variables, sorry, either mounting as a file on file system and using this path in your application. Okay, to summarize, we should treat containers as a code, because putting containers on the infrastructure is still part of the infrastructure. If we think that way, we can have versioning, like mentioned specification of the containers. We've got automated deployment because images are universal, and we've got config maps that allows us to make the customizations. We've got change management because specification is a code actually, so we can review it. We can make a dry run to see what will change in the future. We can apply from the scratch because when we are applying new version of the specification, it overrides the previous one. So it's like a redeployment from the scratch. This helps in some manual guy will change anything in the specification, and then our CD overrides it. And we've got single point of information, like everything is at CD. Okay, now about running Kubernetes and deploying the Kubernetes. Like being mentioned, someone says it's really hard, but I cannot agree. There are plenty of installers, but I will not mention all of them. Just have to focus now on the kops. This is the advanced kops configuration that will allow us to run just by few commands. Everything on the cloud services, like AWS mentioned here. Currently, kops supports AWS, Google Cloud, and vSphere in an alpha version, like a private, probably, cloud solution. So this is really secured topology for your Kubernetes because it spawned two different subnets, one private, one public. In each availability zone, configures NAT gateways, configured your internet gateway, and it's running just like few clicks. How? So kops extends the specification of objects and allows us to interact with the cluster similar like the kubectl command for managing the Kubernetes cluster. So this is the example how we can run some pod inside the Kubernetes cluster. And this is the way how we are creating the cluster from kops. We can call a command line create, or we can apply a cluster specification. Kops extends this API by adding a new object called cluster. We can also interactively edit the configuration of the cluster before applying it. The same with containers. How to getting started? We have to have binaries downloaded. We have to have our domain where the Kubernetes will be exposed, S3 bucket, or our Git repository for storing our state, because similar to Terraform, we have to have some versioning of these objects we are managing, and some EAM roles to manage our resources. And this is the simple command that will create our cluster that was highlighted a slide ago with all of the private subnets, with all free masters, multiple nodes, auto-scaling groups, and so on and so on. How? This is the fuel specification, not the fuel, the specification of the cluster that will be created by the previous command, kops create. We can mention here a few sentences, few additional ways we can customize it before applying, like providing, for example, name of the masters, number of the masters, our subnets, IPs, our version of the Kubernetes also. There's also another object that kops creates called instance group. This is the representative for the nodes in AWS. So each instance group is like auto-scaling group that spans our nodes or masters. We can have multiple instance groups, for example, if you want different nodes with different machine type, like more compute optimized or more network optimized. We can also, with parameter --full, get advanced functionalities of the components of the Kubernetes, like mentioned kubelet. The first parameter, allow privilege. Do we allow to containers to use Flux privilege or not? So this is really powerful in making even configuration of our components of the Kubernetes. How the second day operation works. We are running edit cluster command to edit the specification interactively or apply it from the file specification. Making few commands, update is similar to plan in Terraform, what will change. It will also manage resources that were changed by manual action in AWS account. And then we are executing this once again with yes, that we are allowing, agreeing with these changes. if we change the version of the Kubernetes in the specification file, the Kubernetes will upgrade itself. There is also a feature to, during this upgrade, enable the draining of the nodes. So this is like a maintenance node. Every pods are being evacuated from this node. This node is being recreated with immutable infrastructure by a new version of the Kubernetes, and so on, node after node. To sum up, Kubernetes as a code. We've got versioning because we've got this specification of cluster, either in S3, either in our Git repository. We've got automated deployments because we can just create the same cluster with the same specification and using delayed command just run of our old cluster in minutes and create it from scratch. We have a change management. Still we can review what will be implemented before applying, and this can be reviewed as this is code. And we've got also the testing and quality control if it is put in the CICD, like previously the staging environment, and then if everything works, going to the production. And we've got single point of information. So kops is very great, but it's not all about the features. Because, like being mentioned, it only provides you the way to put your nodes from the images. But how to customize the images, or how to customize what is inside the node? We want, for example, to have additional daemons running GPU or enabling some kernel modules for this GPU, so on and so on. So one option is to have file asset. It allows us to this cluster specification put the content of the file you want to implement. This can be used, for example, for the core OS to disable automatic upgrades if you are not familiar and not like that way of managing infrastructure. We can also use the feature of the registry mirrors to provide trust of our internal mirror. And the really nice feature about the Flux and the labels, it allows us to specify the labels that we'll put on the nodes that will be used for the scheduling of our application, and the labels that they are putting on the infrastructure. Like we want to separate nodes from different teams, like having it well presented in our AWS billing report. And the most important feature is hooks. Hooks allows us to run additional systemd units in the nodes that we are pulled into the cluster. For example, also that way we can make a daemon that will disable update engine of CoreOS. But another example is that we can put this Nvidia bootstrap GPU way to expose GPU of the instance. And that's all for today. I don't think we have time for Q&A, so, but if we have, you can ask me.
Still, we have like 2-3 minutes. Okay. So
I know everybody are hungry right now.
Questions? One question before the lunch? Yeah, we have 2.
Hi, thanks for presentation. Could you please tell us about nightmare? I mean, Kubernetes and data store. So I would like to run containers like could die every day, but you would like to save your data that has been stored by user. So I mean the databases and Kubernetes, how you will deal with it.
Okay, so it's for sure possible, and it's working quite well. Kubernetes have advanced plugins for your storage type. One of the plugins, for example, if running on the public cloud like AWS, you can have dedicated storage using ABS block. Azure file disk or GCE block storage. It also has support for many node tools like NFS or any third party. The list of the plugins is more than 20, I guess. And in your pod specification, pod is actually a combination of the containers you are running within the same EPC namespace and the volume that is being shared between these containers. So yes, it is possible, and yes, it is persistent.
Okay, one more question from here.
Hi. So do you often update your Kubernetes on production, and have you ever run into some problems about it?
I like that question because I hear it more than first time. I didn't have any problems, but it may be due to the tools that I'm using. Yes, I've got staging or testing environment just to test if application is well enough for the new version. I noticed that sometimes the new version of the Kubernetes changes the specification of the pods, like adding new Flux. But by upgrading with the kops, the specification of all pods are being prepared for the new version. Like these new flags are being added with the default values. So I didn't notice any application stop working after upgrading.
Okay, thank you. Thank you for the questions. Thank you for the answers. Big applause, please.